Okay, we're going to talk about quadratic visual patterns. This is the handout we did earlier. And so the first thing I'm going to do is, okay, so some students, they just wanted to count the squares, and they've got 1, 2, 3, 4, 5. Then I've got 1, 2, 3, 4, 2 plus 9, that's 11. Here I've got 16, 17, 18, 19. Here I've got 25, 26, 27, 28, 29. So there's a couple different ways to do this, and I'll show you two different ways. One thing I could do is I could say, look, I've got 3 and 2 here. So this is a rectangle that's 3 times 2, and then we subtract 1. Here I've got a rectangle that's 4 and 3, and here I've got a rectangle that's 5 and 4, and here I've got a rectangle that's 6 and 5. So you could see, and each time we're taking away one of these guys, right? So if I think of it this way, this is equal to 3 times 2, and then we take away 1. This here is 4 times 3, and we take away 1. Here we've got 5 times 4, and we take away 1. Here we've got 6 times 5, and we take away 1. So you can see the pattern. And what I really care about, I mean, I don't care if you get me the 20th one or whatever, but let's figure out what this pattern is. So we've got something times something, take away 1. So in case 1, we've got a number that's 3 times higher and a number that's 3 units higher, and here we've got one that's 2 units higher. Case 2, this is 3 units higher, and this is 2 units higher. With case 3, this is 3 units higher and 2 units higher. So basically, depending on whatever case we have, case X, this is 3 units higher, so plus 3, and this is going to be 2 units higher, plus 2. And we're always subtracting that. So let's just see if how case 4 would be. So in case 4, if I plugged in 4 in for x, we would have 4 times 3, which would be 7. And if I plug in 4 in for x, we would have 4 plus 2, which would be 6. And once again, we subtract 1. And notice it meets the pattern. So what did we do here? We had 7 and 6. And then we took away 1. Okay? So another way that I did it in a different period was I said, look, we've got a square, a square, a square. So in case 1, this is a 3 by 3. In case 2, this is a 4 by 4. In case 3, we've got a 5 by 5. So basically, we've got we add 2 to the case number, and we square that value. So if I added 2 to case 1, that means it's going to give me this length side is a length of 3. Okay, from here to here. And then I would have, in case 3, I would have 3 plus 2, which would give me 5, and that means that distance between here and here is going to be 5. Okay, now, when I play this over a few times, and then here, for example, in case 1, we've got 2 extra squares. In case 0, we had 1 extra square. In case 2, we plugged in 2 here, and we have 2 plus 1. We have 3 extra squares, so and so on. Okay, you may want to press rewind and listen to this again if you need to. Okay, let's look at the next case here. This one was a little bit, this was interesting. I'll explain this in two different ways as well. So one way I think of this one here is we've got a square that's 3 by 3. We've got a square that's 4 by 4. We've got a square that's 5 by 5. We've got a square that's 6 by 6. And we keep having to take away stuff. So in this square, I've got a 3 by 3. So 3 times 3. And we're taking away 2. In this one here, we've got a 4 times 4. And we're taking away 4. And over here, we've got 5 times 5. And we're taking away 6. And here we've got 6 times 6, and we're taking away 8. So basically, if I've got x here, we've got, okay, so in case 1, this is 3 higher, right? This is 3 higher. So in case x, we've got x plus 3 times x plus 3. And we're taking away, what are we taking away? So here, if it's 1, we're taking away 2. If it's 2, we're taking away 6. If it's 3, we're taking away 8. So we're taking away hold on. We're taking away n plus 1 minus 2. Oops, times 2. Let's see, does that make sense? Why am I using n? X. So if I have x plus 1 times 2. So if I let's just rewrite this as minus 2x and plus 2. Or minus 2. Minus 2. So if x is 1, we've got 2 times 1, which is negative 2, and then negative 2, that's going to give me negative 4. If x is 3, we're going to have negative 2 times 3, which is going to give me negative 6, and negative 2, that's going to give me negative 8. Okay, so I could rewrite this as x plus 3 squared minus 2x minus 2. Okay, now I think an easier other way to do this is to think of it as, look, I've got this rectangle right here that's 1 times 3. I've got this rectangle here that's 2 times 4. I've got this rectangle here that's 3 times 5. This rectangle here that's 4 times 6. And we're always adding 2 white squares. We're always adding 2 white squares. So up here, so we're always adding 4. So here I've got 1 times 3. In case 1, I've got 2 times 4. In case 2, I've got 3 times 5. In case 3, I've got 4 times 6. And so you can see the pattern. And so in case 1, this value here is 1 higher, so I'm going to have x plus 1. And then this value is wait, hold on. Yeah, x plus 1, right? And this one here is 3 higher than the case, right? If that case is 2 and this is 3 higher, so I'm going to have x plus 3, right? And then always plus 4, because we got the 4 extra white. So this is another way to write it. You could write it like this, or you could write it like this. Okay, so let's do the backside. So depending on how you're doing this, there's more than one way to answer these. But just to save time, I'm going to go over just one way at this point. Okay. So here I see I've got, in case 0, I have 1 squared and we have plus 1. Here I've got 2 squared plus 1. Here I've got 3 squared plus 1. And here I've got 4 squared plus 1. So this plus 1 is this one square that we're always just adding separately each time. That's our plus 1. Okay. And so in case 1, we've got a 2 by 2. In case 2, we've got a 3 by 3. In case 3, we've got a 4 by 4. So we always have, it's going to be 1 higher squared and then plus 1. Okay. So this length here, x plus 1, tells us how wide our the width and the height of the square will be. Okay. And then the plus 1 is a little blue guy. Okay. You might want to use highlighters if you're unsure of how to do this. Listen to this again, hit rewind, play it as many times as you need. Okay. A student showed me a very clever way of doing this today, but for now I'm just going to go over the patterns that we see here. So here we have a 3 by 3. So this is 3 squared, and we take away 1. Here we've got 5 by 5. So 5 squared, and we take away 1. And here we've got 1, 2, 3, 4, 5, 6, 7 squared, and we take away 1. So case 4, we know it's going to be a 9 by 9 and take away 1. So in order to figure out how, so case 0 would be 1 squared take away 1, which is 0, right? There's nothing shaded. Okay, so how am I going to write this thing squared? So basically, we keep adding 2, right? And so because we have 3, and then we have 5, and then we have 7. So it's going to be 2n, and then since it's 1 higher than that, we have to put plus 1. So let's see if did that work. 2n plus 1. If I plugged in K1, let's call this x. Why do we keep? So if I have 1 in for x, we have 2 times 1 plus 1. That's going to give me 3. Okay. If I plug in 2 in for x, I get 2 times 2 plus 1. That's going to give me 5. If I plug in 3 in for x, I'm going to have 2 times 3 plus 1. So 2 times 3 is 6. 6 plus 1 is 7. Okay. If I plug in 4 in for x, I'm going to have 2 times 4, which is 8, and 8 plus 1 gives me 9. And so that hopefully shows you how that pattern works. All right. I hope this review helps.